Hi everyone, in this video we are going to discuss about how to factor an algebraic expression which is of the form of difference of two cubes, like say for example a cubed minus b cubed. If we have an algebraic expression in this form, we are now going to learn how to factor that type of an expression. So let's get started. So here let's assume that this is a function of a, right? So I'm going to assume that this is a function of a and we can safely do that. I don't see any problem with that, right? So this is like a cubed minus b cubed. Let's assume b is a constant and a is a variable, then we can easily call it as a function of a. And now you see, if we replace the value of a with b, so what I'm going to do, I'm going to use b in place of a, right? So if we replace a by b, then our function is going to look like this. It will look like f of b will be equal to, wherever we have a, I'm going to replace that with b, so that would be b cubed, and then minus the original b cubed that is there already. I'm writing it like this. So now you can see that b cubed minus b cubed, that will be 0. That means from the remainder theorem and factor theorem, we can clearly see that if this function is divided by a minus b, then the remainder is actually, we can call this as the remainder. Remainder is actually f of b. When we divide the expression by a minus b, then the remainder is actually 0. That means a minus b is a factor of the original expression. I have created two separate videos on the remainder theorem and factor theorem. I'll provide the link in the description. Feel free to watch them. So if the remainder is 0, that means a minus b is a factor, and if a minus b is a factor, then there must be another factor also, right? Because a minus b, it's a linear factor, but our original expression is a cubic expression, so there must be another factor which will be a quadratic factor, right? So now let's try to find out that other factor. Well, how are you going to find it? We are going to simply divide the expression by a minus b, and then whatever is the quotient, that will be the other factor, right? So let's do the division. I'm going to do a simple division right here. So first a will go a squared times into a cubed. So our first term in the quotient would be a squared, then here we get a cubed, and then negative b times a squared, that would be minus a squared b, and then we're going to change the sign and do an algebraic sum. So these two will cancel out each other, and we're going to be left with positive a squared b, and then the negative b cubed that we originally have there. And now a will go ab times into a squared b. That means a times ab would give us a squared b. So then our second term in the quotient would be positive a times b. So here we'll get a squared b, because a times b multiplied by a will give us a squared b, and then minus a b squared, because negative b times ab, that would be negative ab squared. Then again we are going to change the sign and do the algebraic sum. So here we will get ab squared minus b cubed, and now a will go b squared times into ab squared. So our third term in the quotient would be b squared. So here we get ab squared, and then minus b times b squared, that would be negative b cubed. And then again we change the sign and do the algebraic sum. This is going to cancel each other, and this will also cancel each other. So finally we are going to be left with nothing as the remainder. So our remainder is 0, right? So now what is the other factor then? Well, the quotient was the other factor, right? So here the quotient will be the other factor, right? So let's highlight the quotient first. So this is our quotient, a squared plus ab plus b squared, and that is the other factor when we divide our original function or the original expression by a minus b. So when we divide a cubed minus b cubed by a minus b, we get a squared plus ab plus b squared. That means a cubed minus b cubed will be equal to the product of a minus b and a squared plus ab plus b squared. Then this can be written as a minus b times a squared plus ab plus b squared, right? And that is the factor form of the original expression a cubed minus b cubed. So if we are given any algebraic expression that can be expressed in that form, then we can easily write down their factored form, which should be a minus b times a squared plus ab plus b squared. So let's take an example. Let's suppose we have an expression like this, 8x cubed minus 1. Now the first thing we should always do is we should check and see if there are any common factors. In this case there are no common factors between the terms. So then we want to see, because it's a binomial, we want to see whether it is a difference of two squares. In this case the answer is no, because there is no square here, it's rather a cube. So could it be a difference of two cubes? Yes, partially it is looking like it could be written as a difference of two cubes, and let's give it a try and see if we can write it as a difference of two cubes. So the first term can be written as 2 times x whole cubed, because 2 times x whole cubed will give us 8x cubed, because 2 cubed would be 8 and then x cubed. And then similarly, can we write 1 as 1 cubed? Of course we can do that, because you raise 1 to any power, it always gives you 1. So 1 can be written as 1 cubed, 1 can be written as 1 squared, 1 can be written as 1 to the power 4 or to the power 5, anything, right? So now you see that our original expression is now looking like a cubed minus b cubed form. If our a is 2 times x and if our b is 1, then this is clearly looking like an a cubed minus b cubed form. So then we should be able to convert it into the factored form then, right? So then what would be the factored form? Well, the factored form would be a minus b. So I'm just creating the template here. A minus b times a squared plus ab plus b squared. And now let's plug in the values. Well, in this case, a is actually 2 times x, so that is a, and b is 1, so that is a minus b, then a squared plus a times b, that is 2 times x and 1, and then 1 squared. And if we simplify this little bit, we are going to get 2 times x minus 1 multiplied by, here we are going to get 2x whole squared, that would be 4x squared, 4 times x squared, and then 2x times 1, that would be 2 times x, and then plus 1 squared, which is 1. And that is the factored form of our original expression. I hope it made sense so far. Now let's take another example. Let's suppose we have an expression like this, 54 times a cubed minus 2 times b cubed. So here, the first thing we should always do is try and find out if there are any common factors between the terms. Now in this case, clearly looks like there is a common factor, which is 2, because 54 is an even number and 2 is also the coefficient on the second term. So 2 must be a common factor. So let's take that factor out and then let's see how it looks. So if we take 2 outside, then we are going to be left with 27 times a cubed and then minus b cubed. And can we write it like this? 3 times a whole cubed, 27 times a cubed can be written as 3 times a whole cubed and then minus b cubed. Now you see inside the bracket we have a nice little form which is looking like difference of 2 cubes, 3 times a whole cubed minus b cubed. So if we assume that this is our a and this is our b, then we clearly see that we have a nice a cubed minus b cubed form. So then this can be converted into the factored form. Alright, let's do that. So the factored form would be like this. Of course, the 2 will remain outside the bracket. That is our first original common factor. So he will stay outside. And then inside we are going to get a minus b, and then times we are going to get a squared plus ab plus b squared, something like that. So now let's plug in the values. Well, what is a in this case? A is actually 3a, 3 times a, and b is actually b. So that would be 3a minus b in the first parenthesis. And then next we are going to have a squared, which is 3a. I'm just simply writing 3 times a in place of a. Then here again 3 times a times b, just the b. In this case b is just a single b, and then b squared. There again I am writing simple b there. So then from here what we get? We get 2. I'm now going to remove the bracket, so that would be 2 times 3a minus b, and then times 3a squared, that would be 9a squared. 3a whole squared would be 9 times a squared, and then plus 3 times a times b, so that would be 3 times ab, 3ab, and then plus b squared. And that is the factored form of our original expression. I hope everything made sense. Thank you for watching. See you in the next video.